Here we are viewing the setup with the liquid nitrogen tank on the left and the steaming fixture on the right as the operators start to run their preliminary setup prior to steaming of the part.
Ready? Warm it up now? Hit it!
Here the fixture is being preheated to ensure that it is at the proper temperature prior to the actual steaming of the part.
Air in the hose.
Here the fixture is being inspected to ensure that the spacers are properly located prior to actual steaming. Here we see the optical bench in the liquid nitrogen tank. Note that there is no boiling of the liquid nitrogen around the part so that the part is stabilized. You do see a light nitrogen vapor arising from the tank, which is normal. Here the temperature of the part is being measured to ensure that the proper temperature has been reached and that the temperature is uniform throughout the part.
197.
After the part has been successfully steamed, the next step is to measure the final residual stresses by the X-ray diffraction technique. From a quality standpoint, it is imperative that the final stresses be measured to ensure that effective stress relieving has occurred. Here is a view of the optical bench positioned on the X-ray table just prior to starting the stress analysis. Measurements are taken at two angles, 45 and 90 degrees. The shift in the atomic spacing between the two angles is a direct function of the residual stress level left in the part. In this scene, we see the stress measurements being taken at the 45-degree angle. Let us now summarize some of the technical aspects regarding the uphill quenching process. In their original research, Alcoa engineers found that in order to achieve optimum stress relief, it was absolutely necessary to use high-velocity steam. Boiling water was only slightly effective. Their results are shown in the chart on the screen. It can be seen that when the liquid nitrogen high-velocity steam approach was used, the level of stress relief realized was 82%. However, when boiling water was used instead of the steam, only 19% stress relief was achieved. Work that we performed on a 1-inch aluminum plate confirmed the Alcoa data. High velocity steam produced a 91% reduction in residual quenching stresses, while boiling water only achieved a 15% reduction. Based on all technical data available and our over 30 years of research and experience with the process, the following conclusions can be made regarding the uphill quenching technique. When using the liquid nitrogen and high velocity steam approach, uphill quenching of high strength aluminum alloys is an effective process for significantly reducing residual quenching stresses, producing more stable parts, and significantly reducing machining distortion.